This is graphing logarithmic functions. And before we start any graphing, we need to know what are the actual x values we can plug in here. And that means we're looking for the domain first. So if we go back to the domain, we're supposed to take the inside and make it greater than 0. So we take the inside and we make it greater than 0. So that is our domain. X must be greater than 0, which means we can't start with 0, but we want something close to it. So 0.1. Just add 0.1 to it if we're going in the greater than direction. And then just keep counting from there. And that should be good enough. I have extra spots if we want more. And then to plug it in, we have to use the change of base because there is no log base 2 on our calculator. So log of x over log of 2. And then now we can plug in the 0.1, but we will always be dividing by log of 2. So we're going to plug in 0.1 into our calculator. So we go log 0.1 divided by log of 2. Close the parenthesis, hit enter, and there it is. Negative 3.32, and that's all we need. So negative 3.32. And we already know log of 1 is 0. So now we go on to log of 2. Clear. And it's going to be log of 2 divided by log of 2. Since it's the same thing, we know it's going to be 1. And now we just need one more. We clear this. So log of 3, close it, divided by log of 2, close the parenthesis, 1.58. And there it is. If you wanted to do a 4, it would give us the same basic idea. Let me clear this. Log of 4 divided by log of 2. And we get 2. So you see how it just keeps getting bigger and bigger, and it's going to keep growing. So when we graph it, we're supposed to take and label our vertical asymptote at 0. So let me grab some red here. Do a little bit thick. So at 0, there's a vertical asymptote. So we know never to cross this graph. Remember, it can never equal 0. So now when we plot this, it's 0.1, which is very tiny here, very close, and there. Oops. Very close, right there. And then we have 1, 0, and then 2, 1, and then 3, 1.58, and you can see how it's growing that way. And then 4 is 2, and there's our graph. So make sure you never cross down here. It just gets closer, and then the other side goes off quickly that way. All right, let's do another one. So here we have x plus 2 must be greater than 0, and solving it means x is greater than negative 2. So that's our domain. So remember, we can't plug in negative 2. So what we have to plug in is something that's a little bit bigger, which would be negative 1.9. So we're going that way. You can't do negative 2.1. That's not bigger. So negative 1.9, and then negative 1, and then 0, and then 1. That should be good enough. So let's plug them in. So we have negative log of negative 1.9 plus 2. Now, and again, you got to divide it by log of 2. And there we go, 3.32. And then the negative 1 will give us 1, so that again is 0. Plug in 0, we would get 2, and log of 2 over log of 2 is 1. So we get negative 1. And you can enter all this in your calculator if you want. Let's do the last one, which is 1. Let's clear it. So negative log, and then we have to do 1 plus 2, close it, divided by log of 2, enter. And we get negative 1.58. Alright, so let's draw our vertical asymptote, and it's at negative 2, right there, and we can label it as x equals negative 2. We can label that one as x equals 0. Those are our vertical lines. And then now we get to graph. So we're going to go negative 1.9. That's really close to the asymptote. And then it's 3.32 right there. And then it's negative 1, 0, 0, negative 1. And then 1, negative 1.58. Do you notice now that these are just going in the opposite direction? So we are going up and then down like that. It's because of the negative. Remember, the negative flips it across the x-axis, so it takes it from here over here and so on. So our negative values become positive and our positive become negative because we have an opposite here. So instead of having a negative 3.32, we have a positive 3.32. And instead of a positive 1, we have a negative 1. Instead of a positive 1.58, we have a negative 1.58, and so on. So if we were to keep going, at 2, it would be negative 2. Okay? But that's it. This is all you have to do. You need a vertical asymptote, and it's the number from our domain. And then you just pick some values from that domain. So there's our steps. Find the domain, then find the vertical asymptote and label it x equals 0 or x equals 2. It's based on our domain. And then plot some points. And remember, you want to pick one that's close, and then just keep counting out. Okay, let's try one more. This one's a base 3, and then I'll let you try that one. Alright, so with a base 3, we got to find our domain. So you have x plus 1 is greater than 0, so x is greater than negative 1. Okay, so we can't start with negative 1. So what's one that's very close? Negative 0.9. You're basically just adding 0.1. So if you don't know where to start, take negative 1, 1 negative, and then add 0.1. That gets you really close to it. Okay? So our vertical asymptote is at negative 1. Let's draw it. Let's put that in red so we know where it's coming from. It's right there. So that is our line that we cannot cross. Right there. And we're going to plug in some points. So negative 0.9, and then the next one off is 0, and then 1, and then 2. And this time we have to divide by log 3. So the formula we're going to use is log of x plus 1 over log of 3. So I want you to plug those into your calculator and see if you can get the answer. So remember, I'll give you the first one. Make it exactly how it looks. It's log of negative 0.9. Right? Plus 1, parenthesis, and then divided by log of 3, because that's our new base. So we're always dividing by that base. And there it is, negative 2.095. Now you got to plug in 0 and 1 and 2. Hit pause, give them a shot. So you should have these points and a rough graph that looks like that. Now try the next one. Hit pause and see if you can do the whole thing by yourself. Now it does have a little trick here, is 1 minus. So to give you a helping hand, this is the formula you're going to be plugging into. You just change the base on the logarithm like that. And there's what you should have for your graph. There's just one more thing, and that's domain and range. And as you can see with the domain, we already found it from the very beginning, and it's x is greater than negative 1. So you want to write negative 1, comma, infinity, or you can say x is greater than negative 1. And then over here, it's x is greater than 2. So it would be from 2 to infinity, or x is greater than 2. But you must use parentheses because it'll never actually hit that value. Remember, it can never cross the value that gives it a 0 inside. And then the range is nice. Negative infinity to infinity, and then negative infinity to infinity. As you keep plugging in points, you will always get much more and more and more negatives as you keep getting closer and closer to the asymptote. And as you keep going farther and farther out with your x's, you're going to get more and more y's, and it'll just keep going on forever. Same with this one, it'll go on forever, and it'll go on forever up. So we're going to have as many negatives as we want, and as many positives as we want. All real numbers. Thank you.